Live from Utrecht, this is Bitcoin
Explained.
Hey Sjors,
Hello.
you just came back from Advancing Bitcoin, is that right?
That's right.
Technical conference.
Yep.
How was that?
It was fun.
Did you learn anything new?
Many little things.
Anything we can discuss on the podcast?
I don't think so. Maybe later, but not.
Well, I knew that because we got a topic for today. Today, we're going to discuss P2SH, which somehow we never did before.
Well, we've mentioned it a few times, but we haven't done a full episode on it.
Yeah, we probably mentioned it many times, and it was actually a suggestion by someone. I don't remember who it was. Sorry if you're listening, dear listener, but it was someone on Twitter that suggested it, and then I went over the episode overview list, and I realized we've never actually done an episode on P2SH. So let's do it today. But first, Sjors, your favorite part of the show, you wanted to give us, what's it called again?
A boostergram.
Sjors, explain what you're doing.
I'm just going to read one boostergram.
This is also, you sent me a couple of links on how people can stream the sets to me, is that right?
That's right.
I'm not going to do it, Sjors. I decided this is your special moment. This is your special moment in the show. This is
you don't have to read
love affair with the listeners.
Well, you don't have to read any of the boost yourself. It's just that I now have to look at how many sats we got and then send you half and deal with invoices, which is annoying.
I don't want half. It's all yours.
All right.
Dear listener, if you want to make Sjors rich, if you want to make me regret this decision, send all your sats
Sounds
to
good.
Sjors. Do you want your own intro tune for this part of the show, Sjors?
No, that's all right.
I can make one for you.
All right. So we got a
Sjors stacks sets. Sjors stacks sets. Sjors stacks sets.
That is pretty good intro tune. Let's keep that one. For 20,000 sats from @LawBitcoin saying appreciate you. So it's a pretty nice one. I think you're already regretting it.
20,000? Oh my God. Okay, Sjors. Back to the show. P2SH. So the way we're going to structure this episode is because I think probably a lot of our listeners know what P2SH is, although we might go into some details that not everyone knows about. But then also what we're going to do is we're going to discuss a little bit about the history of P2SH.
Exactly.
And that's actually largely based on an article that I wrote with Pete Rizzo 3 years ago now, something like that, because it was kind of the first big Bitcoin controversy, first big Bitcoin war. You know, it wasn't as big as a scaling war, obviously, but it was kind of like a prelude to that in a way. It was sort of the precursor, the prequel to the big scaling war.
Yeah, there were at least like 20 angry posts on Coin Talk.
Yeah, and there was some bickering on IRC, and there was the dark wall. Amir Taki got involved with his own website, and like there was some debate about it back then.
Yeah.
But
Speaking of IRC, yesterday I tried to find the IRC logs from 2011, and all the websites that link to old IRC logs pointing to a website, Bitcoin something, which doesn't exist anymore. So it's a bit annoying.
Wait, the logs from 2011 are gone? Is that what you're saying?
I don't know if they're gone. They're not on the sites where the other sites link to. So if somebody still has IRC logs, I'd like to know where they are.
Oh, I mean, I can look that up for you. I'm sure I would have that somewhere, unless it got deleted.
We'll find out.
Anyways, okay. So let's just start at the beginning, and I think we'll start with a more sort of high-level description of P2SH, P2SH. Sjors?
Yeah,
what is P2SH?
Because what we'll get to is that there were actually 3 proposals, but they're all really doing P2SH. It's just that one of them came to be known by that name. But P2SH just means pay to script hash, and there are multiple ways to pay to a script hash. So what it does is...
Well, I guess my question is about what we call pay to script hash today, but I think your point is that what you're going to describe kind of applies to all of them.
Yeah, exactly. Okay. So
Okay.
the idea is that when you want to receive Bitcoin, you need to tell the sender where to send it to, and what you're really telling them is what script to send it to. And usually that script is just like, okay, whoever has the private key belonging to the public key can spend it, but the script can be more complicated. And this is a problem because the more complicated your script is, the longer it is. And so that means that the sender has to pay you fees, and that the addresses can look very small, or the addresses can look very long if you have a long script. So in order to avoid that, the idea was to send your coins to the hash of a script, because a hash is always the same length. And so therefore, the idea of paying to script hash is that the recipient gives you not the script itself, but the hash of the script. And then you turn that into a special. Your wallet will then do its magic and make sure that the coins are sent to the right place. That can only, and then when recipient wants to spend it, they have to reveal the original script. And the precise details vary per proposal, but that's a general idea.
Right.
You reveal the script, the blockchain checks that it matches the hash of the script that you previously said it would be, and then you have to satisfy whatever that script says.
Right. So back in the early days of Bitcoin, if you wanted to receive money, if you wanted to lock, how do I say it? What's the best way to put this?
Encumber money is
Let's
one
say
word.
you want to say, I want to receive money from you, Sjors.
Yeah.
But I want to receive it in such a way that the money is locked into a multi-sig. Let's say just a multi-sig.
Yeah.
Then what I would do in the early days, well, actually it wouldn't even work in the early days, right? Because of
It would.
policy rules. What's it called?
Well, it would be difficult to get the transaction mined.
Exactly,
Yeah, you'd
yeah.
have to work with a miner because of the standardness rules.
Standardness, that's what I was looking for. But let's ignore that for a second. So if I wanted to receive coins in such a way that it's in a multisig, I got several keys dispersed in several locations. That's how I want to receive the coins. Then I would actually send the script to you, and you would send it to that script, right?
Yeah, you would. Yeah, exactly. You would have to tell me, okay, this is my multi-sig script. Please
Yeah.
send it here.
Right.
And that was annoying because there was also no address format for it. So it's a very difficult UI or user experience.
Right. So then you're going to have to pay the fees for the fact that the transaction is now bigger because it contains a whole script.
Mm-hmm.
And also it's immediately public. It's immediately visible on the blockchain that it is sent to a multisig, which is maybe not great for privacy.
Yeah, so the privacy, the nice thing about paying to script hash is that the privacy is slightly better, or at least you have privacy for longer, because eventually if you spend it, the script will show up, but until you spend it, the script will not show up.
Yeah, and you're the one paying the fee, rather. Like, I'm the one who wants a complicated multi-sig address, but then you have to pay the fee for including it in that address, right?
Yeah,
So
before P2SH, yes, the sender would have to pay a higher fee in order to send to somebody with a complicated setup, which kind of doesn't make sense. And now it's more fair in the sense that if you have a complicated setup, anybody can send to you. It doesn't cost them anything extra. But once you want to spend from your complicated setup, then you have to pay the extra fees.
Right. Yeah, no, I was just summing up how it would work before P2SH hash was there. So I sent you the whole script, so that's big, so you have to pay a big fee, even though I'm the one who wants to use a complicated script. And then also it's slightly worse for privacy. So that's why developers early on in like 2011 came up with this idea, let's instead send it to a hash. And then I give you just the hash, I don't give you the script, I give you the hash. And then when I want to spend it, I reveal the whole script, and then anyone can check that the script matches the hash.
Exactly.
And that's what I spend it from. That's how it's only then that I include all the multiple signatures in the multi-sig case, right?
Yeah.
So that's the basics of P2SH.
Yes, in general. And so the hash of a script happens to be the same size of the hash of a public key, which means that it will just look like an address. You start with a 3 instead of a 1. So that's nice too.
Right. Why is it 3, not a 2?
Because it's a version number. So the first number in the address, in the legacy addresses, we've done an episode about addresses. The first letter represents a version number of the address scheme. So if it starts with a 1, which is not actually a 1 because it's base 58, but we're not going to bother you with that. That means that it has to be interpreted in a certain way, and if the address starts with a 3, it has to be interpreted in another way.
But why is it not a 2?
Because the numbers 1 and 3 do not actually represent the numbers 1 and 3, because it's base 58. We did a whole episode about that, Aaron. You should just listen back to the original episode about addresses.
I definitely forgot about it. I thought the reason was because 2 was already used by testnet.
Yes,
So
that's
one
probably also
mainnet, two testnet, three, next one.
that could also be true.
Okay.
It doesn't really matter. It's just that once you're sending to it, you have to put the wallet that's sending has to put something on the blockchain, and the only thing that's in the address is the hash of something, either the hash of a public key or the hash of a script, and that's not enough to put on the blockchain. You actually have to put more information on the blockchain as the sender, and the version number tells your wallet exactly what to put on the blockchain. So they're standard script templates that go around the hash.
Moving on. So this was the basics of P2Script hash and why it was implemented. But now we'll sort of take a trip down memory lane, and get some go back to some historical context. So first of the first proposal that would do something like this. So this P2Script hash idea was around, and then the first idea that was actually proposed and implemented and almost deployed was called op-eval. So op-eval, I think the right way to looking at it was a way of doing P2Script hash, right?
Yes, and arguably the most obvious way to do it, though of course that depends on what you were thinking of at the time when you were designing it. But basically the idea of op-eval is that, again, you as a sender, you just get a hash and you put that on the blockchain. Now the recipient wants to spend it. They reveal the original script, and then the way that original script is run is by this opcode called op-eval. So that means the sender has to put the word op-eval somewhere in the thing on the blockchain, and then the recipient will actually put the script, and then the script gets executed.
Yeah, so to be perfectly clear, in case anyone is confused at this point, op-eval is not actually in Bitcoin. This was an early proposal that was rejected.
Yes.
Okay, so who's putting op-eval? Maybe you just said this, but who's putting op-eval where exactly?
The sender has to do it. So this is one of the things you implicitly communicate when you have a version number in your address. Now, in this case, this standard was never materialized, but maybe the address would have started with a 7 or something. And then as a sender, you get a hash of a script, and you put on the blockchain something like op-dub, the hash of the script, op-eval. A little bit longer, but something like that.
Wait, so I'm the one who wants to receive money from you in a multisig address. Let's just stick to that example.
Mm-hmm.
So in the case of op-eval, what exactly do I send you? Do I send
the hash of the script, so the hash of your multisig script.
Okay, and does this script include op-eval?
No.
Okay, so I just sent you the script of the multisig. I send it to you. What do you do?
You sent me the hash of the script of the multisig.
I guess I can do either, right? But sure, I'll send you the hash because
that's the whole point, basically, to make it simple. So you're sending me the hash. Then what I do is I create a script pub key on the blockchain. That's where the coins are going. And I think it says the first instruction is like duplicate whatever's on the stack and then put the hash there. And then it says compare the thing that's on the stack with the hash. And then if that's true, then you call op-eval. And this is a very similar pattern to how you spend from a public key. Because with the public key, you're also basically, the sender is putting the hash of the public key on the blockchain. And then the receiver, when they want to spend it, they have to reveal the actual public key.
Okay, sorry, do you put op-eval in the input or in the output?
In the output.
Okay, so I send you the hash, and then you put that hash in the output, and you put op-eval next to it.
Yep.
Okay, and then when I want to spend the coins, then I include the script.
Yeah, basically what you will do when you're spending it, you include the script, and you include whatever is necessary to satisfy the script.
Right, and do I put op-eval anywhere?
No.
No, okay, so then other nodes on the network, they're gonna look at...
They start basically, because you always start with the signature side. So what they'll do is they'll say, okay, I'm putting some signatures on the stack. I'm putting the actual script on the stack. And then I'm going to run the script pub key, which will say, okay, you need to duplicate the hash of the script. No, I don't know what you need. Anyway, it basically says, okay, now you should check that the hash of the script actually matches the script that was put on the stack.
And that's because...
And then you encounter this eval instruction, and that's when you execute the whole script and when you need the signatures.
Just to make sure that I'm understanding this. So when nodes verifying new transactions, what does up eval mean to them exactly? It means that they need to compare
It means execute the script that's on the stack. So
shouldn't they always do that?
No, normally you are executing a script, and the script can put things on the stack, like numbers, etc. Right. The stacks are like plates, basically. So you can put numbers on the plate, and you can say, okay, is this number on the first plate, is that the same as the number on the next plate? But you do not execute code that is on the stack. So things that are on the stack are numbers or text or keys or whatever it is, or dates, but they are not code.
Okay.
And what this eval thing does is, no, pretend that what is on the stack is not a number or a text, pretend that it's code, and then just run it like that.
Okay. Well, you say pretend, but it's actually code then, right? Or?
Well, so this is where the downside of this proposal comes in.
Okay.
But maybe some people have worked with JavaScript in the past. And in JavaScript, you can, there's also a command called eval, and it's extremely dangerous. So generally, when you're building a JavaScript web application, you really should not use eval. And the reason for that tends to be that you cannot predict what that thing is going to do if you're just trying to analyze your JavaScript code. So your JavaScript code might see something like eval and then a piece of text. So if you're just analyzing the code, you might think, oh, it's just text. What could go wrong? But now it turns out this text is actually treated as code. So you can no longer just treat text as if it's text. And the same thing goes with Bitcoin. That's sort of where the downside of this eval proposal comes in. Normally, when you see a piece of Bitcoin script, you can look at what it's going to do because you can see all the opcodes in it. And you can see, okay, it's pushing some number, whatever. It's pushing some text, doesn't matter. And you can reason about it. And then after you've done some sanity checks, that's when you actually run the script. But with eval, you cannot do that anymore because anywhere in this script could be a piece of text that initially you think is just text, so you've ignored it. But now it's suddenly code. So you should not have ignored it. But conversely, if you're just looking at the text and you're treating it as code, well, maybe it really is just text and you should have ignored it.
Okay.
So it just creates
So
hell,
it makes it
basically
hard to do a sanity check. So
yeah,
what is
a sanity check without running the code?
What is insane in this context? What is it you're afraid of?
Well, there's many things you'd be afraid of because my understanding is that this would actually make Bitcoin Turing complete, and Turing completeness is bad. Basically, because it means you can execute any arbitrary program, which could include loops, infinite loops.
Okay,
for example. So one of the things you might be afraid of is an infinite loop.
That's the core risk, right?
That's one of the risks when you have basically when you can run any program you want. Well, one of those programs could be an infinite loop where you're trying to validate the block, and you will never finish validating it because you keep going in circles because you have a loop.
Can you give an example of an infinite loop, just for people like me that this is not obvious to me what that means?
Well, how you would do it, like normally in a programming language, you can just
what
say,
is an infinite loop?
Do while, which basically, you just basically say, okay, go in a loop until some condition is met. Usually that's how a programming language works. And then inside that loop, you might print something on the screen. And if the condition that to leave the loop never happens, then you never leave the loop. So you keep printing something on the screen line by line by line, and you never stop.
What is a loop?
Basically, I guess a circle of code. So you run an instruction, and then you go to the top of the loop, and you run the instruction again. So it is a piece of code that you keep running again and again until you, for some reason, stop running it.
Okay, so I'm going to just try an example.
So typically you might loop from 1 to 10, mm-hmm. and you print the number. So you would say for I is 0, and then you say print I, and then at the end of the loop you do I++, which increases I, and then you check if I is more than 10, you exit the loop. That's one example.
If I tell my code, I write code that says hash this piece of data with a nonce until it spells Sjors is the king. And then I will keep hashing that until it says that. Is that like an infinite loop?
Well, that's probably an infinite loop, yeah, because that's never going to happen. That condition.
I mean, it might happen at some point, right? But
yeah,
it's practically an infinite loop.
Yeah, exactly. It's just as bad because it will grind your computer to a halt.
So and then the problem is to verify if a transaction is valid, you first have to basically keep checking all kinds of different things, and
Yeah,
it
and
takes too
so an
long,
infinite
and
loop in Bitcoin
new
would probably
blocks
be
come in, and it
Right.
just grinds your node basically can't keep up with the blockchain because it's still verifying an infinite loop from a transaction from 4 years ago.
Yeah, and I guess an example of this infinite loop could be that the thing you're calling eval on says opt up, which means duplicate, and then it says op eval again. And so what you would do is you see eval, you duplicate the actual thing that you want to evaluate, and then you call eval on it again, and then you're calling eval on something that's that same string again, which says, okay, duplicate myself. And so you keep duplicating the thing that you're trying to evaluate. And so that will be an infinite loop. Now, there were in this proposal some protections against that.
Well, just to be clear, was this the example that you just gave? Was that sort of the specific concern with upheaval?
Well, that was one example of how it could be to an infinite loop.
Okay, yeah.
But there was a protection against that in the implementation of it. It would basically only allow 2 loops, or to recurse. That's the term, basically, recursion. So how often can you go back inside yourself, inside the loop? And there was a limit of 2, but I think then there was a mistake in the implementation that protection didn't work, and so people got a little scared.
Yo, what is going on, guys? We are proud to have Voltage as a sponsor of this episode. How many of you developers out there have wanted a streamlined infrastructure provider for your particular project? Well, I'll tell you what, Voltage is the Bitcoin infrastructure provider you have been looking for that makes building on Bitcoin quick and easy, whether it's Bitcoin nodes, Lightning nodes, BTC Pay, and so much more. But don't take it from me. Just ask the guys over at Amboss, Sphinx, Podcast Index, and Thunder Games, and so many others that you guys already know and love. Their enterprise-grade products make it fast and easy to build, deploy, and scale your next project. So make it easy on yourself. Even normie plebs can use the dashboard or API. Don't wait before the next block confirmation. Let your team focus on building great products and let Voltage handle all the rest. Voltage is your go-to zero management Bitcoin infrastructure solution.
Okay, well, this got real technical real fast. But do you think we've now explained the problem with upheaval?
Yeah, so basically, in theory, you could have fixed all these specific issues, but the general risk remains when you have something like eval in any programming language is just kind of dangerous. So you don't want to, you preferably don't want to do it. It makes it more difficult to reason about the code, very easy to make a mistake, and one mistake and you have an infinite loop.
Okay, so is it fair if I summarize the problem with upheaval in that it opens the door to potentially infinite loops, which would kind of break Bitcoin?
Yeah, I guess so.
Okay.
And keep in mind that Ethereum does allow something like eval, and the reason they get away with it is because they have gas. And so you use up your gas and the loop won't be infinite because you run out of gas at some point.
I see. Okay. So that was the problem with upheaval. And then this was discovered very last minute by Russell O'Connor back in 2011. It was ready to be deployed. And then Russell O'Connor said, guys, what are you doing? You got to stop this right now.
Yeah, he literally said, you guys need to stop what you're doing and really understand Bitcoin.
Right, yeah. And then the core developers at the time, which were led by Gavin Andreessen, but also a lot of the kind of currently known developers were already involved, right? Greg Maxwell, Peter Wuille, Luke Dasher, Amir Taki also.
Yep.
Anyway, so they figured out we got to figure out something else.
Well, they didn't even agree on that, I think, initially, because there were 2 possibilities. Either you do something completely different, or you just play whack-a-mole, basically. So you stick with the op eval, you fix the specific bug you find, but there might be another bug, but you just hope that there isn't.
Right.
And
then Gavin Andreessen, he proposed what we would call pay-to-script hash today. So really, upheaval is kind of a form of pay-to-script hash. So we're just going to name this one pay-to-script hash because is what we're calling it today, I guess.
Exactly. So he could have basically stuck to the op eval proposal. I think he tried initially, but then I guess somehow he got the idea of doing it in a different way that was safer.
So what is this different way and why is it safer?
So this different way is that we have a type of script. So when on the blockchain you see a script that has a very specific form, so I don't know, it starts with op equal, then it has a hash, and then it starts with something like that. If the script interpreter sees that particular form, it will understand that what it tries to do is be a P2SH transaction. Because from the old node point of view, it would just see the hash of a script, and all it would do is check whether it matches the script that you're putting on the stack, but it wouldn't do anything. So from an old node's point of view, such a template just looks like doing nothing, giving the money away. But from the new node's point of view, they'll recognize this. They will take the script, the actual script, and run it.
Yeah, so you're getting into a topic that we haven't mentioned so far, which is that pay-to-script hash as well as op-eval can be implemented as a soft fork. This was kind of a discovery by the Bitcoin developers at the time that this was even possible.
Yeah, that's fun to read on the forums and probably also in IRC. You can find a log that, they discovered that there are ways to do soft forks this way, by either in the op-eval proposal by saying we take an existing opcode that does nothing.
Yeah, the op-nobs.
The op-nob. Mm-hmm. And then because it does nothing, old nodes will think, okay, this transaction is valid because nothing changes. And new nodes will actually do what the new opcode says. And that mechanism was new for the developers, but very likely Satoshi knew that this would be possible, because otherwise, why did he put the op-nobs in there?
Right. Yeah. Well, so let's get into that.
It was rediscovered, essentially.
Right. So let's get into that a little bit. So the op-nobs, these are opcodes put in there by Satoshi, which old nodes or non-upgraded nodes or whatever you want to call it, if they see op-nob, they will just consider the transaction valid.
Well, they don't consider the transaction valid necessarily, but it doesn't change anything about the validity. So if whatever happened before op-nob was valid, then after op-nob, it's still valid.
Right. But then these op-nob codes can be reinterpreted by newer nodes after a soft fork, and then they start to mean something else. So in this specific example, they would have started to mean op-eval after that.
And although the op-eval concept was abandoned, the idea of doing a soft fork this way by having a script that means nothing to all nodes, or like it just means take the money for all nodes, it has a more strict interpretation for the new nodes.
Right. The thing, though, is that with op-eval, there was an actual explicit reinterpretation of an op-nob. And then with pay-to-script hash, that was not the case. So it's used the same logic for a soft fork. It just didn't reinterpret an actual op-nob.
Exactly. What it interpreted was a template. So if a transaction looks like a duck, for example, your old rules would be, we just take a photo and we say what animal it is. We see a photo and we say it's a cat or it's a dog. And the new rule would be, but if it's a cat, we're actually going to look at the skin color of the cat and do some other game. And this caused some friction because, it depends on your taste, I guess, whether or not you think this particular way of doing it is good or bad.
Yeah, it was described at the time, even by people that supported it, like Amir Taki. He said, I don't know the exact quote, I don't know if we have it here, but he definitely called it a hack.
Well, and you could ask, was this the will of Satoshi, that kind of interpretation? Because the op-nob system was, at least you could think that the op-nob system was intended to be used in the way that op-eval was using it, whereas this idea of using a template was not basically in there. So mostly I think Luke Dasher was very not happy with this way of doing it. Mm-hmm. And so for you could say aesthetic reasons, but he might look at that differently. So he came up with a different proposal that was somewhere in between. It didn't use an op-nob, I think. In fact, I think it repurposed opcode separator or something like that. In any case, he basically came up with an alternative design that didn't use this templating mechanism. And then there was a lot of drama. And the downside of the drama was that not much attention was really paid to the real proposal that Luke was doing. And there was much more bickering back and forth, at least on the forums. And so, I haven't studied that proposal in a lot of detail either. I mean, I wasn't around it. I can say some things about it, but it might not be the most fair description.
Yeah, so let's get to that in a second. Just to clarify, so first there was op-eval that turned out to have these problems with recursion. Then the alternative that was proposed by Gavin Andreessen was, we'll just call it pay-to-script hash, even though all of them are really pay-to-script hash, but this one is like explicitly called pay-to-script hash. And then like Luke Dasher came around. He said, I don't like this at all. Let's do, and this is what we call, in our article at least, check hash verify. So CHV is what we call this.
Yeah, but again,
I don't know if he called it that at the time, probably though.
Right, but you see, it's really the same thing, right? You're checking a hash, namely the hash of a script, and you're verifying that, it's actually a valid script.
Oh, you just blew my mind, Sjors. You're right. It's the same thing.
Yeah. So it's a way of you can pay to a script hash, or there's probably other things you could have done, but
check hash verify. So okay, and you wanted to explain how that works. Kinda. You have some. So again, this one wasn't implemented. So if you, our dear listener, don't really understand how this works, it doesn't even matter because it's not in Bitcoin. But if you're interested and curious anyways, Sjors is going to explain it to you now.
Well, not entirely. So I think it's BIP 12, right? That was the number given to it?
No, right?
Oh,
the debate was between BIP 16, which was pay-to-script hash, and 17.
So I don't completely understand how it works. All I know is that it did not use the templating technique.
I think op-eval may have been 12, by the way.
It didn't use eval, but it did something similar to eval. I believe it was still treating text as code, but I might be wrong about that part. In any case, one of the things that it contained was the legendary opcode separator, and maybe one day we'll do an episode about opcode separator. I don't understand it. I think it generally gives people two kinds of responses. Either they don't know it, and so they have no response, or they know it and they fear it.
This is something that is in Bitcoin or is not in Bitcoin?
Yes, it is in Bitcoin. It's been there from the beginning. It led to the arguably biggest bug ever, which is that in the beginning you could take everybody's Bitcoin.
Right.
That had to do with the opcode separator.
So it's non-standard?
I'm not sure. I think it has become non-standard, or at least it's become non-standard in certain circumstances.
Okay.
What you do see is a trend that newer soft forks like Segwit and Taproot will make more and more restrictions on that particular opcode. And there was a proposal by Matt Carollo, the Great Consensus Cleanup in 2015, that would also make it invalid outside of Segwit or P2SH. Though that was controversial because there might be some really obscure transaction out there that uses it. So anyway, that is really almost FUD, I guess. I'm saying, oh my God, this proposal had this evil opcode inside of it. But it did. But at the time, of course, it wasn't probably considered that evil. So really, the question was, you have three proposals. Which one are you going to pick? If you ignore all the drama, it's like you have three options. What do you want to do? Mm-hmm. You also kind of want to do it quickly because that was sort of Gavin Andreessen's point. People are losing Bitcoin left and right. We should have more advanced script functionality. Now, I don't know how much of that actually got used in the end. But,
pay-to-script hash is used all the time, right?
Well, if you ignore wrapped Segwit, it's only used for very standard multi-sig transactions. Probably 2 or 3 that you could have done with raw script.
That still counts.
Yeah, but you
counts.
could already do those.
That was the whole point.
You could already do those with bare multisig if you just make them standard and invent an address format. So yes, was it worth the risk? I mean, that's the question, right? Is it worth making a change to Bitcoin that could break it and almost would have broken it in the case of op-eval?
Well, I want to first ask... So I want to take one step back because I feel we moved on before I was ready to move on.
All right.
Okay, so how does check hash verify, Luke Dasher's alternative proposal, if you know this, how did it prevent the loop-de-loops?
I'm not sure if it did. I think it did.
I mean, it must have, right? Because that was the whole point.
Yeah, I think you somehow split the script and the hash of the script in a way that it's interpreted, but you're not using eval, so you can't duplicate it. So eval would allow you to sort of recursively duplicate stuff. But I think here you would just have the hash, and then you would have the script itself. And so I don't think you'd have any recursion or loops.
So yeah.
As you can see, I did not study that proposal in enough detail.
That's fair. Yeah, so I think the real situation, I think op eval was kind of done, right? So then the debate was really about pay to script hash and check hash verify.
Yeah, and then of course the pay to script hash was implemented by Gavin Andresen, who also implemented op eval and who was the lead maintainer. And so that probably got the most attention, the most review. So that also tends to give it a little bit of favor almost by default if the other proposal was equal.
Yeah, and also very important, there was ultimately kind of really a vote between the two, and that was a hash power vote. Like the miners could pretty explicitly just vote for one or the other.
Yeah, I think both of them kind of went on a campaign. Well, I think Luke Dasher used his own pool to campaign for it, but they may have also convinced some other ones. So there was something similar to BIP9, though much more primitive. The idea that miners would put something in the block to say that they like the proposal or not. So that happened.
Yeah, well, it was kind of a precursor to BIP9, I would say. Well, where BIP9 was more about readiness signaling, like that idea kind of evolved over the years. Mm-hmm. Well, for the very first time that hash power signaling was used, it was arguably actually like a vote. Like that's really what happened the first time, I would say. So that's how pay to script hash got. At least is what I remember.
That was one element in it, but I mean there was debate about whether that was a fair way to do it at all, because the lead maintainer, of course, had access to many more miners. So from a social point of view, he would be able to get more votes that way because miners would not look at the actual code. But there was another thing that happened, which I think was more fair, at least relatively. I think after some of the initial heated debate died down, some of the core devs at the time, so Greg Maxwell and Peter Ruijler and a few others, were asked to take a few days, look at all three proposals, and then they made a little chart or a little diagram.
Oh, that's right.
Yeah, saying okay, this one I'm absolutely against, or this one I have a preference for, or this one is fine. And if you look at that little table, the P2SH also won, in the sense that nobody was completely opposed to it, not even Luke, although he really didn't prefer it. And it had the preference of some of the experienced developers.
Yeah, I'll include the article Rizzo and I wrote in the show notes where this whole debate is sort of outlined.
Yeah, so I think it was a little bit more to it than just a brute vote, basically. There was more review on it, but nowadays, I think if you had a situation like this, it would not be resolved in a matter of days and weeks. And back then it was resolved in a matter of days or weeks, which is way too quick for something like this. Right,
yeah, and I think, well, actually I'm fairly sure that, for example, Greg Maxwell, who at the time preferred BIP 16, has come around and said that BIP 17 would have actually been better.
Okay, I didn't know that, so that could be the case.
Yeah, in Greg Maxwell's style, he just mentioned this off the cuff in some Reddit comments somewhere, so it's hard to find. But right. I'm pretty sure that that he did it. I just don't really remember the reason or the motivation.
Right. I read a post by him during these days where he was articulating very well why he supported the P2SH variant that we have now. But obviously, as time goes by, he could have changed his mind on it.
Yeah. Okay, so we've discussed what pay-to-script hash is, both in a sort of general sense as well as in a more specific sense of the proposal that we actually call pay-to-script hash and that we use today.
And to make a very quick jump to the future, we still use this pattern, basically, in the way we in SegWit and in Taproot, the idea of there is a hash and the blockchain magically knows that this hash should be revealed as a script and then the script should be executed. So this whole idea of pattern matching is still there. And so apparently it's good enough to keep repeating it, though there is also the argument of not writing new code if you don't have to.
Yeah, well, I was going to say, so we've discussed P2SH more generally, more specifically, and then also some of the proposals that were rejected, op eval and CHV. Gave an idea about the historical context. Is that the episode, Sjors?
I guess there's two little things that might be fun to mention briefly. One is that there was some screw up with the deployment. At least that's what I read in the op overview of soft forks in general. Apparently, because of this mechanism, which was kind of a vote, but also kind of an automatic activation, depending on how you run your software, a subgroup of miners activated the soft fork too early, and so they started rejecting blocks. Basically, I don't know if they activated op eval accidentally or they activated P2SH, But anyway, they did it too early, and they weren't in the majority, so they couldn't enforce a soft fork. So it's like an accidental UASF, except they weren't like super passionate about it, so they just went on. I mean, at the time, Bitcoin was worth nothing, so they didn't lose like a giant fortune. And the other thing that is probably fun to mention is I think the soft fork was backported to even older versions of Bitcoin Core, like version 0.3 and 0.5. And apparently something went wrong doing that. So those versions of Bitcoin Core would actually also fork themselves off the network, so they had to be sort of undone again. So I guess the question to Jameson Lopp is, was that a hard fork? But I don't know.
Yeah, this was the P2SH was the first soft fork after Satoshi left. So it was also the first protocol upgrade after Satoshi left. So it was the first time that developers started to figure out how to actually upgrade Bitcoin and who should do what. So that's that's kind of the start of that whole debate, and it's very interesting in that sense. But I would also say that's like a whole other episode
yes.
So as far as P2SH itself comes, I think we've kind of covered it at this point, right?
I think so. So
okay.
In that case, thank you for listening to Bitcoin
Explained.